Alright guys, so doing what I told you guys I was going to do, give you a couple problems. I know these mole conversions, there's a lot of information, it's a lot of steps, a lot of things to take in. So up here on the board I've drew out and wrote out 6 problems, and throughout this we're going to change some subtle things to just show you a little bit of the differences, okay, and show you some different ways that you can go off that mole map in doing these mole conversions. If you have questions, just ask me. I'm going to try and go through this pretty fast, throw some stuff at you real fast. If you don't understand what I said, pause the video, scrub it back, do what you got to do, watch this again. But please, please pay attention. These videos are not here for you to just look at and go, oh, press play and sit with your headphones in and say, oh, okay, alright, he said this thing. You actually got to pay attention to what's going on, okay? So we're going to start off easy. I'm going to rotate between colors of blue and purple, okay? So we're going to start with the blue marker. First question we have is how many moles are in a sample of 78.4 kilograms of magnesium, Mg. You don't know the name of it yet, but you will shortly learn it. Its atomic number is 12. Please, please, please remember, important information is where we're going to get information, is where we're getting information from is this periodic table, which I will give you on your quiz. So, here's what we have to do. We first have to find out where are we starting, okay? We're starting right here with 78.4 kilograms is information I give you. If you haven't caught on yet, I have a trick hidden here. The trick is you cannot convert these kilograms, so you have to convert them on your own. Write down the number you got that you start with, times 10 to the something or another. We're going to find out what that something or another is. We have kilo, which exponential value is 10 to the 3, and we're going to the base unit of grams, which is 10 to the 0. So it's 3 minus 0, which will be 3. You should be good at that already. If not, go back and watch the conversion video for metric conversions and come ask questions on that. So now we have this in grams of magnesium, which is good. That's what we're wanting. So we have 78.4 times 10 to the 3rd grams of magnesium. We're going to set it over 1. Now it's time to do the conversion. So here on this conversion I'm looking, it's a one step. How do I know it's a one step? Because of what I'm asked to find. I'm asking you to find me moles. If you're giving that or you're asked for it, remember it's a one step. That's not including that metric conversion here that I had to do. So that prefix conversion I did for kilograms to grams. So I'm looking for moles. So it's always going to be 1 mole, and in this case it's magnesium. I want moles on top, so that's what I'm going to be left with, and I want grams of magnesium on the bottom, so grams of magnesium will cancel. So I look, where does this information come from that I need to put here? It comes from the periodic table of elements. We covered that in class. So magnesium, we have 24 points. Darken that in so you can see it. 305 grams of magnesium. This is good because grams of magnesium will cancel and it'll come out very nice for me here. Punch it in the calculator. 78.4 second, comma 3 divided by 24.305. So that'll give me 3,225.6737 moles of magnesium. So there's that answer. Okay, simple enough on that one. It's not that bad. We're just going from grams in the moles. Alright, not bad. We've done a lot of those in class. Okay, so just like the second one that we've done a lot in class. So we're on this problem now, and this is how the problem reads. How many atoms are in a sample of 0.6832 moles of sulfur? Atomic number 16. Remember, I'm going to give you these atomic numbers because you haven't memorized these elements yet. So, write down what we start with. 0.6832 moles of sulfur. Darken that decimal in so you can see it. Put it over 1. Okay? Do you need the periodic table for this? No, you do not. Why? Because you're starting with moles and you're going to atoms. So 0.6832 moles of sulfur. I need to be left. I want the moles to cancel, so 1 mole of sulfur is equal to how many atoms of sulfur? there is a number, a very special number by the name of Avogadro's number that you best remember, and it is 6.022 times 10 to the 23rd. We find out what that'll be equal to 0.6832 times 6.022 second e to the 23, and that'll be equal to, you know what, let's just put equals down here, 4.1142 times 10 to the 23rd atoms of sulfur. Hopefully right here you guys are feeling good. Okay, these are kind of like the ones we've done in class. They're really not that complicated or complex in my opinion, and hopefully you're doing good with them. If you have questions with these, please come ask me. As you've seen, they're just one stops. Ooh, man, if I can get that to come off, there we go. Square that up. Okay, if you have questions, please come ask me, guys. Do not just sit around and just wait and struggle. If you have a question, now is the time to come ask, okay? So, up here, we're going to start on problem 3, and it's going to get a little bit more complex as we're going through these problems. So let's get it, pump a little bit of steroids up in it. Alright, so the question reads, how many molecules are in a 7.3 gram sample of N2O5? Now you do not know what that's called yet. We have not went through nomenclature, but we will later on in class. But this is dinitrogen pentoxide. So we're just trying to find out just a little, little piece right there of what's to come in class. It'll be pretty fun when we get to that. Everything starts getting really interesting. Anyway, how many molecules are in a 7.3 gram sample? So here's the thing. Where am I starting? That's right. Hopefully you said mass. So we're starting with a 7.3 gram sample of N2O5. We're going to set that over 1. And now we need to do a conversion. Now I know this is asking me for molecules, but please understand something. You're starting at grams. You cannot just go straight from grams and straight to molecules. There's the middle way. We call these mole conversions for a reason. You have to get to moles first. So I want moles, so I need that on top. 1 mole of dinitrogen pentoxide. So N2O5, that's my first conversion, and I need to cancel the grams of N2O5, but I have a problem. Here's the problem. This periodic table is information based for the elements, okay? If you remember back in class, we talked about having to find the molecular mass. This is what you're having to do. We must find the molecular mass for dinitrogen pentoxide. It's not that complicated. Remember how we talked in class about it. I said first thing, we're going to write down the elements we have. So we have a nitrogen. I'm going to do this in green below it. I don't want to take up a whole lot of erasing here. So I have nitrogen and I have oxygen. Okay, if you're looking for them, nitrogen's atomic number is equal to 7 and oxygen's atomic number is 8. So they're right next to each other off of your periodic table. So I have some information over here off to the side so I don't have to keep holding the periodic table. The first thing I do is I write down the elements I have, so nitrogen and oxygen, and I write down the number for those atoms in that molecule. So in here, nitrogen, I have 2 of them, and I know that because this number right there is a 2. So 2 is going to be times nitrogen's average atomic mass, which is found on the periodic table, which I remember to be 14.007, and that's grams per mole. Oxygen, I have 5 of them because that's a 5 right there. And I remember oxygen's is 15.999 grams per mole. Okay? Hope you guys are feeling good from here. And I'm not going to do all this math out through here and show it all up on the board. But you solve these out, you add these 2 together, and it's going to give you what I'm going to punch in my calculator real fast here. If you don't understand what I'm doing, please come to class tomorrow or before we take the quiz on this and ask me what I did so I can make sure you understand how I got 108.009 grams per mole. Okay, you have to understand where I found that molecular mass out. I'm going to write it in green so you can see that this is, well, I better not do that. That'd be a bad idea. Anyway, I'm going to take this number and put right here. So, we'll put, we'll do it in purple. 108.009 grams. And this is good. This is good because now I have my grams of dinitrogen pentoxide have canceled out, and I'm left with moles. But you're not finished. We're not looking for moles of dinitrogen pentoxide. We're asked for molecules. So you are not done. Make sure you can tell when you're finished and not finished. So in this case, I have to keep going. All right, I need moles of dinitrogen pentoxide to cancel out. So it's 1 mole of dinitrogen pentoxide, which is down here. It'll cancel everything out, but then I need to be left with molecules. I'll write this really small here, running out of space, N2O5. And that number for here will be 6.022 times 10 to the 23rd. Hopefully you have this in your memory to know that that is Avogadro's number. Okay, so now the moles of dinitrogen pentoxide will cancel out, and this will be leaving me with molecules of dinitrogen pentoxide, which is what I'm looking for. Therefore, I'm going to grab myself my calculator, and I'm going to push this all in. Hopefully, you've learned how to know what's happening here if you're multiplying or dividing. It's mathematical properties, so it's 7.3, and I'm going to divide 7.3 by that 108.009, that molecular mass we calculated for it, because this is on the bottom. This is in my denominator. Since this is in the numerator and denominator, we will divide, and then I'm going to multiply by Avogadro's number because Avogadro's number is in the numerator. So 6.022, so E23, and I find my answer to be equal to 4.0701 times 10 to the 22nd power, and these are molecules. Again, running out of space. N2O5, that dinitrogen pentoxide, and we'll box that in to let everybody know that that's our final answer for that one. A little bit longer there, okay, but it's all good. I have faith in you guys that you can do it. Now here's one that you, if you're watching this on the day that I released it, you probably are going to be a little bit lost, but don't worry about it. We're going to hit it more in class tomorrow, but we're definitely going to cover it before we take the quiz. So, how many molecules are in a 23.6 kiloliter sample of CO2? You guys should know this name. CO2 is carbon dioxide. We exhale it. Okay, how many molecules are in a 23.6 kiloliter sample of CO2? This is an important time for me to inform you. I must tell you something, and I'm going to write this in purple so you will get it. I'm going to put the at symbol just because I like putting the at symbol. STP. And then we would put the question mark after this. This is the important thing. It must be at standard temperature and pressure. A trick I can throw at you is I can tell you not at standard temperature and pressure. If I tell you that, then you cannot solve the problem, because remember the box and that conversion factor that you're given, it must have standard temperature and pressure for it to be equal to that with that volume and that conversion. So I'm going to switch back to the blue to work this out. So we're going to take what we're given, but notice something. What is your conversion factor you're going to use? 22.4 liters? Well, there's a problem here. I gave you kiloliters. So we have to yet again do another prefix conversion. We have to do one of those metric conversions. So we're starting with 23.6 times 10 to the something another, and I got to figure out what something another is. Yet again, it's going to be the same thing as before. Kilo is 10 to the third exponential value, and the base unit is just 0. So it's 3 minus 0, which will be 3. If you can't remember how I'm getting that, you need to go back and watch the metric conversions and follow those rules that I taught you. So 23.6 times 10 to the third liters of carbon dioxide. So we're where we need to start now. So we're set over 1. Now in this, can you go straight from a volume to molecules? Guess what? No, you cannot. Remember, you have to go to moles. This is why we call these mole conversions. Remember, you got to go through moles. So we got to convert this to moles, which is not bad. I want 1 mole of carbon dioxide gas. Okay? It is 22.4 liters of carbon dioxide gas. That ran together a little bit there. It's carbon dioxide in liters. Are you done? No, because look at your units. The liters of carbon dioxide cancel, and you're left with moles of carbon dioxide. But you're not yet finished here. You have to keep going. So we're going to draw this on out. I'm looking to cancel out moles, so my 1 mole of carbon dioxide goes on the bottom. I'm trying to get to molecules. What number goes with molecules? Hopefully you're answering the video and you just said Avogadro's number. I'm going to use an abbreviation for it because it's shorter for me, so that N sub capital A. And these are molecules of CO2. Hopefully you remember what that number is, that it's 6.022 times 10 to the 23rd. So from here we're going to do something a little different. On this point, here's what we're going to do. Punch it in the calculator. Hopefully you got this by now. I hate to have to take so much time to punch this in the calculator. Remember, this is division. That's in the numerator. That's in the denominator. So 22.4. And then I'm going to multiply because that's in my numerator. So times 6.022, second function, comma, leaves me with the E, 23, which will equal out to be 6.34446 times 10 to the 26, and these are molecules of carbon dioxide. So molecules of carbon dioxide. Alright, now I want to show you something here. Okay, the special thing here is we started with the volume. If you remember from your mole map, you start at a volume and you go to moles. From moles, you can either go to the left or to the right. In this case, we went to the right. We went from molecules. But you can go to the left. So let's say we change this question around. So it's no longer this, but let's flip it around. How many grams are in a 23.6 kiloliter sample of CO2, which is carbon dioxide, at standard temperature and pressure? Very important. Must say at standard temperature and pressure. I do, so therefore you can solve it. Here is the only thing that's going to change. And I'm going to put this in purple so you can see the difference. You're still going to get to moles. We'll still go here. We're still going to do this same conversion. But now that we're at moles, we no longer are going to use Avogadro's number. That'll be changed. I'm going to erase this answer here. Hopefully you got that. Your new conversion factor must be set up. I want to cancel out moles, so moles will go on the bottom. That stays the same, but now I'm asking for how many grams. I want a mass. So up here at top, I'm going to put grams of CO2. Is that an element? No, it's not. It has 2 elements within it, so guess what you need? You're going to need to calculate the molecular mass like we did here with the dinitrogen pentoxide. So in that case, there's my green marker. What elements are in here? Carbon and oxygen. I have one carbon. Remember, there's nothing there. It's like in math class. If there was just an X variable within an equation, what do you look and say? Well, there's clearly a 1 there, or I'd have nothing. So we have this 1, and it's going to be times the molecular mass, average atomic mass of that carbon, 12.011, and that's grams per mole for unit conversion. Keeping you guys with your units, getting used to it. Oxygen is 2 times 15.999, and that's grams per mole. And we're going to do the same thing. You'll multiply those out in your calculator, and you're going to add them together to give you the molecular mass that you're looking for. Yet again, if you do not understand what I'm doing, you need to come see me. So 2 times 15.999. And we'll find out that the molecular mass for carbon dioxide is 44.009 grams per mole. Why are you saying that grams per mole? Remember, the number goes with grams. If I can't stress it enough to you in class, let me stress it to you in a video. It goes with the grams. So, what number goes here? That's right, 44. Man, that's a horrible 4. 0.009. You're going to do the same calculation that you've already done, except for we're not doing Avogadro's number now. Everything's going to stay the same. You're still going to have this 23.6 times 10 to the third liters. You still have to do that prefix conversion, and you have to divide it by the gas the box that I showed you guys with this value, the 22.4 liters that you need to memorize. But then you're not going to multiply it by Avogadro's number. We're going to multiply by the molecular mass. So it's 44.009. We no longer need those exponentials. We now have an answer to be 46,366.625 grams of carbon dioxide. I feel like you guys are getting this. I hope you are. Alright? Oh, I'm getting a little wore out. So let's keep rolling. Okay, we've done a couple good problems here. But let's keep going over here. So, roll a little bit faster on this one. I'm not going to explain so much because I feel like the video is getting really long at this point. Sorry, because it probably is, and you're watching, you're like, gosh, can he ever shut up? No. This question reads, how much does a sample of 2.613 times 10 to the 24th power 4 million units of calcium fluoride weigh? So, where am I starting? I'm starting with formula units, and I'm trying to get to a mass. So, I'm going to take my number I start with. It's 10 to the 24th. That's 4 million units of Ca. I guess I'm going to have to write it. Formula, I'm writing this small, by the way. I have virtually no space on this board right now. Units. I'm going to set that over 1. I have to get it into moles. So I want 1 mole over Avogadro's number. I'm going to abbreviate it, which cancels out my formula units. And then I'll multiply this by, I hope this is in the camera, I'll end up multiplying this by the molecular mass of the sample. So it'll be grams of CaF2 up top and 1 mole down bottom. To find out what that is, punch it in a calculator. It is, let's see, what is it? Oh man, I never looked at that. 18.999 0.998. Calcium 40.078. You add that all together. I'm not going to do the math. I've done enough. You guys should be good there. 0.74 grams. So then we're going to take that, and so it's 2.613 second e to the 24 power. We're dividing. Why? Because I've got their numbers in the denominator here. So divide it out. And then I'm multiplying. Why? Because it's in my numerator. So 78.074. To give me an answer, this is the answer, by the way, 338.7701 grams of calcium fluoride. That's a mouthful right there. I'm wore out saying all that. Okay, last problem down below it. What is the volume of a 73.4 micrograms sample of sodium dioxide? You're going to have to do the same step here, but realize there is a metric conversion. So we're going to have 73.4 times 10. You should be able to do the metric conversion to get you -6 grams. That's over 1. I got to get it to moles, so 1 mole of SO2. And I need to divide it and cancel out the grams of SO2. You should know that you're going to find that off of your, calculate that off, find the molecular mass for sodium dioxide, which is the SO2. You're going to calculate that off of the periodic table information. So it'll be times 15.999 plus 32.66. You'll find that out to be 64.064 grams. And then we're going to multiply, I'm running out of space, hopefully this makes it. I'm now in moles, grams have canceled. I'm in moles, and I need to get from moles to a volume. What's the constant? Hopefully you remember it's 22.4 liters over 1 mole of sodium dioxide. And you'll throw this all together. Find you an answer. I'm dividing because that number's in the bottom. So 64.064. And then I'm going to multiply by the 22.4 because it's in my numerator. And I'll find my answer to be a volume of 2.566 times 10 to the -5 liters of sodium dioxide. There we go. Guys, I know that was a lot of information. I know it was a lot thrown at you at once. I did this to help you out. You got plenty of examples I've worked, all those from simple all the way to complex. All this over here was what I'd say was a little difficult. Okay, if you have questions, come see me. I'll answer the questions off of this video if you have them. Just come see me. I mean, that's all I can say to you. But if you'll have no questions, I'll see you in class.